To solve this maths Olympiad question, e to the power of x squared minus 1 equal to x, let us start with using a very important law of indices. That's the division law of indices. If you recall that if we have a to the power of x minus y, this can be equal to a to the power of x divided by a to the power of y, right? And that is from the division law of indices. Now, if we apply that in that expression, we're going to have the exponent of x to the power of 2 dividing the exponent of 1, right? And this will be equal to x. Great. Now, how do we simplify this further? To simplify this further, let us multiply both sides with the power of the exponent of negative x squared. That way, we can be able to do away with the power of exponent x squared. So if we do that, we're going to have the exponent of x squared divided by the exponent of 1 multiplying the exponent of negative x squared, and that will be equal to x multiplying the exponent of negative x squared, right? And from this expression you can see that this can easily cancel out this, but we will not do that. In case of those who don't know what we did, we're going to simplify it so that those who are just learning can follow up. If we simplify it, we're going to have the exponent of x squared multiplying the exponent of negative x squared, and all of this will be divided by the exponent of 1, and this will be equal to x multiplied by the exponent of negative x squared. Now, if we simplify this, we'll find out that these two exponents, according to the law of indices, will become the exponent of x squared plus negative what? Plus negative x squared, all divided by the exponent of 1, and this will be equal to x multiplied by the exponent of negative x squared. So finally, you find out that this whole expression will give us the exponent of 0 divided by the exponent of 1, and this is equal to x multiplying the exponential value of x what square. So from the laws of indices, anything raised to the power of 0 is equal to 1. So this expression will now give us 1 divided by the exponential value of 1 will be equal to x multiplying the exponential value of negative x what square. Great. So what do we do from here? At this point, we are going to simplify. And if we simplify, we'll take this to this point, x multiplied by the exponential value of negative x squared to be equal to 1 divided by the exponential value of 1. So having done this, we are going to mend this in such a way that we can use the Lambert expression. And remember the Lambert expression. From the Lambert expression, we found out from using the Lambert W formula, we'll find out that if we have the Lambert of a multiplying the exponent of a, this can be equal to a. So if we mend this expression and this such that it can look like the Lambert, we can be able to simplify that. And to achieve that, the only thing we need to do is to multiply or take the square of both sides. If we take the square of both sides, we'll now have that expression to give us x multiplying the exponent of negative x squared, multiplying all squared, equal to 1 divided by the exponential e squared. And because 1 square is equal to 1, so if we simplify that, we will simply make that expression now to become x squared multiplying the exponential value of negative 2 x square, and this will be equal to 1 divided by the exponential value of e square. So what do we do here? In order to make all this similar still yet, we have to multiply both sides by negative 2. If we multiply both sides by negative 2, that is multiplying both sides by negative 2. Multiplying both sides by negative 2 will now give us this whole expression multiplying negative 2, and that will give us x squared multiplying the exponent value of negative 2x squared, right? And this will be equal to 1 divided by the exponential value of 2 multiplying negative 2. So what do we have here? If we do this, we are going to have this expression to give us negative 2x squared multiplying the exponential value of negative 2x squared, and this will be equal to 1 divided by the exponent of square multiplying negative 2. That expression will simply give us negative 2 divided by the exponential value of 2, right? And this will give us negative 2x squared multiplying the exponential value of negative 2x squared. So if you look at the left hand side, it's already mended to Euler's expression. So we can easily make this also. From this expression, we can see that this can be equal to, recalling that if we have 1 divided by n, 1 divided by n can be n to the power of negative 1, right? So that means this can become negative 2, the exponent value of negative 2, right? And this will give us negative 2x squared multiplying the exponential value of negative 2x squared. So what do we do on this other side? On this other side, you can see that is more of the Euler expression. So now not the Euler, the Lambert W expression, because we need to mend this in order to look like the Lambert W expression, which is this, and we have done that. If you look at that expression, you will now find out that if we apply the Lambert W expression over here, which is the Lambert of A multiplying the exponent of A, will be equal to A. If you apply it over here, you see that that expression will simply give us negative 2x squared equal to, apply it here, you find out that that will only give us negative 2. Great. Now from this expression, we can continue our solution, dividing here by negative 2 and dividing here by negative 2. We'll simply have our x squared to be equal to 1. At this point, we can find the value of x. And what are the value of x? If we take the square root of both sides, we can clear the square, and this will give us equal to plus or minus the square root of 1. While this cancel out this, the value of our x will be equal to plus or minus 1. So from there, we can see that the value of our x, let's assume our x1 is equal to 1, and then our x2 is equal to minus what? Minus 1. Now the question is, are these definitely the solutions to this expression given to us? Fine. Okay. We're going to verify to find out if that is actually the solution. we are given the exponent of x squared minus 1 equal to x. Now we are going to insert the solution into that mass expression to find out if a solution is actually right. Minus 1 equal to x. Now with the value of x equal to 1, with the result of x equal to 1, if we insert that into that expression, we will have this expression to be the exponent value of 1 square minus 1 equal to 1, right? Will it be equal to 1? Will this be equal to this? If we simplify this, we're going to have this expression to be the exponent value of 1 minus 1. Is it equal to 1? 1 minus 1 is equal to 0. So we'll have the exponent of 0 equal to 1. Remember, from the laws of indices, anything raised to the power of 0 is 1. So here, 1 is definitely equal to 1. Which tells us that x equal to 1 is definitely a solution to that expression. Now let's try out using the value x equal to 2. With x equal to negative 1, right? Let's apply that expression there. We'll have the Euler of negative 1 square minus 1. Is it equal to negative 1? Let's do that arithmetic. If we do that, we're going to have that expression to now give us the exponent value of 1 minus 1 equal to negative 1. Is it equal to negative 1? This will give us the exponent of not equal to negative 1. From the laws of indices, you agree with me that this is equal to 1. And is this equal to negative 1? This is not equal to negative 1. So hence, our x2, which is equal to negative 1, is not a solution to that expression. Hence, we are going to reject it as a what? As a solution, and have our only solution as x equal to 1. So you see, from this expression, the only solution we have is x equal to what? 1, and that is the solution to that mass expression given to us up there. I know you did enjoy watching this mass video solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. Thanks so much for watching, and bye bye for now.